All right, 8th graders, this is to help you with question 8 on CR12. It says triangle ABC represents a piece of stained glass on a craft table. The following follow the directions and draw 2 different locations for the piece of glass. Translate ABC 2 units left and 6 units down. So translate, we know, means to slide. We're going to slide it 2 units left and 6 down. All right, let's do that. Label the new triangle A prime, B prime, C prime, D prime. What are the coordinates of point A prime? So we have to go 2 to the left, 6 down. So I'm just going to start at A, go 2 to the left, and then 1, 2, 3, 4, 5, 6 down. And I'll make sure I label that A prime. For B, I'm going to go 2 to the left, and then 1, 2, 3, 4, 5, 6 down. I just want to point out that if A to B is 1, 2, 3, 4 units long, A prime to B prime had better still be 1, 2, 3, 4 units long. Okay, good. Because you don't change the triangle, you just slide it. So the side lengths have to remain the same, the area remains the same, the angles remain the same. So let's see, if I take C and I go 2 left, 1, 2 left, and 6 down. 1, 2, 2 left, and 1, 2, 3, 4, 5, 6 down. Right there is C prime. If I connect those up, you are going to notice from B to C was 2 units long. Well, B prime to C prime is also still 2 units long. I'm just going to draw in the hypotenuse of that triangle. Okay. And they asked for the coordinates of point A prime. A prime is -1, 1. Starting at the origin, you go 1 left and 1 up. So that is -1, 1. All right. Now we're going to reflect ABC across the line x equals -1. All right. Draw the new triangle. Label it A prime, B prime, C prime. I bet you here they really want double primes. I'm going to put double prime. Oh, no. They want us to go back to the original ABC. Gosh, that's crazy. They want us to go back to the original ABC. I didn't realize that. I wasn't reading it carefully. I was going to take this one and reflect it over x equals -1. Good thing I then look back. Math is so much about just attention to detail. So we're going to flip or find the mirror image of the original ABC across the line x equals -1. So I need to first know what the line x equals -1 looks like. And what I could do is I could get some points on that line. X has to be -1. I don't know, maybe y is 3. X has to be -1. Maybe y is 7. X has to be -1, and then I pick whatever I want for y, maybe -5. Then I can plot those points. -1, 1, 2, 3. -1, 7. -1, up 7. -1, -5. 1 left from the origin, 5 down. You're going to notice I have this beautiful line here. I'll make it a nice dotted line. Mostly because then maybe I can make it straighter. So this is your line of reflection. All right, this is your line of reflection. That is the line x equals -1. You'll notice x equals -1 is a vertical line. So x equals some number, some constant, that will actually be a vertical line. And students often find that bothersome because they're like, but the y-axis is vertical. Yes, but x equals -1, they want all points that are 1, x equals -1, 1 to the left of the origin. That's what they want. They want to draw a line for any points that are 1 to the left of the origin. Or not the origin. There's the origin. 1 to the left of the y-axis. If you start at the origin, always move 1 left and then go anywhere you want, up or down. All right, I digress. So we're going to now reflect ABC across x equals -1. All right, so if I look here and I say point A is 2 to the right, A prime will be 2 to the left of that line of reflection, right? If A is 2 to the right of your line of reflection, A prime will be 2 to the left of your line of reflection. So B is 1, 2, 3, 4, 5 to the right. So now I go to my line of reflection. Careful, don't go to that y-axis. Go to your line of reflection. Go to x equals -1 and go 1. I don't think I did B from the line of reflection. Starting at the line of reflection, how far is B to the right? 1, 2, 3, 4, 5, 6. Excellent. It's 6 to the right of that line of reflection. So you go back to the line of reflection, and I'm going to go 6 left. 1, 2, 3, 4, 5, 6 left. And you'll see, even like as a math teacher, like visually, sometimes my eye goes back to that y-axis. It can't. It has to go to whatever line they tell you you're reflecting over. Let's take a look at C. If I look here, 1, 2, 3, 4, 5, 6 to the right of the line of reflection. So then I have to go 1, 2, 3, 4, 5, 6 to the left of the line of reflection, and I label that C prime. Now if I draw in, even if it's a little bit ugly, if I draw in this beautiful new triangle, I can see the coordinates for C prime are -7, 5. -7, 5. So when you're reflecting it over any line, you literally count how far you are away from that line. You can do that also when you're reflecting over an axis. You can always just count how far you are away. So there's no need to really memorize, quote unquote, memorize rules for reflecting. All right, I hope that helps.